Hi, welcome to the interest lecture series. And we are in the testing hypothesis unit. This is our lecture number 8. And in this lecture, we're going to talk about the hypothesis testing on the two population means. In the lecture number 7, we started the hypothesis testing with one population mean. So if we want to test a certain population mean equal to some value, and that's what is lecture number 7. So for the lecture number 8, we want to test, in these two populations, are their means, or we can say the averages are the same or not, or is one is greater than other and other is smaller than other. So we're going to test the two populations here, okay? So now let's go ahead and go to our lecture notes. And let's start. Okay, so the first thing is here, when we talk about the two populations means here. So the first thing is we need to be careful about the two populations. That means I am taking two samples. Okay, so I'm taking the two samples and each sample from each population here. Okay, so when we do the population hypothesis testing, and when we try to compare their means or their averages here, and one of the very, very common practice is instead of just go ahead and jump into the z-test, the t-test, one of the things like from the practical point, sometimes if you plot it first, because we know the graph, they're telling a lot about the stories, right? So the plotting the data and it sometimes will be very good. So we typical the tools we use is we typically like to do the side-by-side box plot. Okay, so like basically, so if you want to compare the two populations, so for the first population, maybe you can say, hey, I do a, the box plot, and this is my box plot here, right? So this is your population number 1. And then you can say, okay, for my another box plot, I can do like here, so okay, so you have a two population. So by just looking the graph, you see, that these two population probably, if you want to compare the means, and probably is obviously, will be very significant different, right? Or you will say the red mean is bigger than the green mean here. And then also by plotting here, you can see whether they have any outliers. Sometimes those outliers will affecting your test result. But by looking the graph, so if the testing, you obviously you see this is very significant different, but if your testing show you the result is not significant different, then probably there are some outliers and affecting, your testing results here. Okay, so that's why typical we like to do a side-by-side comparison, do some graph, and then the graph you can give you a very clear ideas here. Okay, so like in here, the hypothesis testing. Okay, so right now I have two populations, right? So I have, I call this the population number 1. So population number 1 have some mean. This is, I call this mu1. And the population number 2 probably have some means here. I said is mu2 here. Okay, so as before, like we did several hypothesis testings, right? So the non-hypothesis will be pretty straightforward. That will be mu1 equal to what? Mu2, right? That means I assume these two populations means are the same. as always, what could be your alternative hypothesis? We always have threes, right? So we had first one is mu1. We say, hey, they are not equal to. Okay, then the second one, just like we did of many other hypothesis testing, we have u1 greater than u2, and we have mu1 less than mu2 here. Right, so we always have three alternative hypotheses here. And now, just like before, so if this is mu1 is not equal to mu2, so what happens here? So this will be, so this could be what? This could be is the two-tail test, right? So those are your rejection regions. So if the mu1 greater than mu2, and so this will be what? This will be one tails, right? So this is one tails, this tail. And then mu1 less than mu2, then which tail here will be this tail here. Okay, so it's very similar. As you can see, it's very consistent. When we start with one population proportion test, then we talk about a two population proportion test, then we talk about one population mean test. And it's always very consistent about your hypothesis and where is your rejection regions here. Okay, so in here, it's just like we do the population for one population test. And we have two different tests here. So the first one here is when the population sigmas is known. Okay, that means sigma 1 and sigma 2 both are given, or we say both are known here. Then we say this is we're going to use what type of the test? How we're going to use the z-test here. Okay, so we're going to use the z-test. And then what is the z-test, the test statistics here? The z-test statistic will just be the z, okay? And then you have what? You have x1 minus x2, okay? And then you can minus, if you know the differences, you can minus mu1 minus mu2, or if you say mu1 equal to mu2, then it would just be minus zeros here, right? So this test you can do, so like for TI-84, so it's just x1 minus x2. And what is your denominator? This is what we call is the standard errors here. So the denominator will be, so it's a sigma 1 square over n1 plus sigma 2 square over n2 here. And these values here, this is the, so this values here is sigma 1 square over n1 and sigma 2 square over n2. This is, we call this the standard error. Sometimes you see the SE, some book they will use the SE here. And so this is the z-test. Like I said, I write the z-test statistics here, but when you go to the, when you go to use the TI-84 or R, you can just, program that in, or they will just, you just need to input what is your x1, x2, and sigma 1, sigma 2. So you don't really need to remember these formulas here. Okay, because this is z-test, right? So it is just like, it is just like we do any other z-test. We have the critical value. So let me try to write our critical value one more time. And also you see here, this is pretty consistent, right? We do the same thing. So this is a 10% critical value. When your HA is mu1 is not equal to mu2, or your HA is mu1 greater than mu2, or HA is mu1 less than mu2. So We still remember what is this? I think we should kind of remember that, right? So we did it many times. So this is 1 point of what? 1.64 or negative 1.64. Then this is 1.28, negative 1.28. All right. And then we call this the most popular one is a 5% one. So we still have 3 alternatives. So here's mu1 not equal to mu2. So this is mu1 greater than mu2. And this is mu1 less than mu2 here, right? So still remember what is the 5%? We have a 1.96. Or is negative 1.96. Then what is here is 1.64. This is negative 1.64, right? Then the other very popular kind we say is what is 1%, right? So this is 1% significance level. We still have 3 alternatives. So mu1 not equal to mu2. HA is mu1 greater than mu2, and the HA here is mu1 less than mu2 here, correct? Okay, so now let's try to do one more time. Do we remember what is this? This is a 2.58, negative 2.58, okay? Then we have a 2.33, and a negative 2.33. So in fact, you can just use your regular calculator, calculate what is the z-test, and then compare to those critical values, right? So those are the critical values we talk about. It depends. You are in the one side, one tail, or two tails, right? So those are the critical values here, right? So those are the critical values here. Right, so those are the critical value, and the those area is rejection region. So you can compare your test statistic to see your test statistics is inside the rejection region or not. Okay, if it is, and then you will be able to, decide is reject or not reject here. Okay, of course, then you will have to, find the p-value. So if you need to find the p-value, then you need to use the, the technology. So that's why it's the p-values here. All right. So now let's take a look at what type of the code we're going to use the t-value, find the t-values here. Okay, so first let's take a look at the TI-84. Okay, so if you use the TI-84 calculator, and it is pretty easy here. So you go to the stat, like always, right? And then after you go to the stat, you go to the test, okay? After you go to the test, you go to the two population z-test. Okay, so you use the two population z-test, and let me see. Let me show you the calculator's functions here. So here, okay, so you do stat, right? So you do the stat, then you do the test. And so the test here, so you go down to here, you say two simple z-test here. Okay, so that is what you need to use. So in here, I guess instead of I need to change this once here. Oops, what did I do? Okay, so in here, let me erase that. So here really is the two simple z-test here. Two simple z-test here, okay? So this is how do you use the TI-84 calculator here. Okay, so how do you use the R Okay, so here is the R code here. So let me kind of separate that out so you won't get confused here. Okay, so for the R code, so this is how do you do the R code here. So first things here, right? So you said SE, you defined what is your, what is your, like the standard error. Then you have SQRT, that's the square roots, right? So it's all lower cases here. And then you put your sigma, right? So you put your S1 square, whatever the value you have, right? And divide by N1, then plus here, you put your S2 square divided by N2 here. Okay, so you can double parentheses, so make sure you don't mess up that. Okay, after you do that, then the next things you do the XP NORM here, right? So the NORM, so what do you put over here? You said X1 minus X2 over SE, right? So you just calculate here, and then you say comma, then you say mean equal to 0, and the SD equal to 1. So remember that, right? Remember we talked before, we said R is pretty cool. So R will give you the graph, right? So they will give you a tail. So we'll give you a graph like in here. So like this side, maybe like this color, and right? So in here, the only thing we need to be very careful is when the R show you here, the p-values here, right? So p-value is always will be the tail value. And now you be careful here, if, right? So if it's the two-tail test, so remember, like we did before, so the p-value will be ever be equal to 2 times what is your tail value here, right? Because the R, they only give you one tail, but I know, for the two-tail test, right? So you're going to have both like in here, right? So that's why you need to times 2. Okay, like a TI-84, you don't need to worry about it. TI-84 is already programmed in here, right? So the TI-84, the p-value will be this, whatever the TI-84 calculator give to you. You don't need to times 2 or don't times 2. And because it, the TI-84, they program in when you choose which tail you do, it automatically, calculate that. All right. Okay, so let's, right now this is a good place to stop. And so let's take a break here. Then we will come back here, our second video. Then we're going to talk about what happened when the sigmas are not given, is unknown. Then how do I do the test here? Okay, so now let's have a good day, and we'll come back to finish, take a break, and we'll come back to finish the next ones here. Okay, bye, talk to you later.